All right. So it might be due, it might be. Okay. So, we had set up our Venn diagram. This is problem 7B. We have 68 kids. No, we set this up, we didn't finish it. We did this much of it. Now, you may have finished it on your own, because you were motivated, but this is as far as we got. Green was 43, purple was 23, and yellow was 32. So all this was from the problem itself. We hadn't done any math. Okay, so we had that before. Now, it's time to fill in the rest of the Venn diagram. So do you remember how we did this the other day? We put X, Y, and Z, or A, B, and C, whatever letters you want, in the missing chunks. And then we said, okay, the whole green ball, the entire green ball has to add up to 43. So 21 and X and Y has to add up to 43. And then X and Z and 10 has to add up to 23. Those are the purples. And Y and Z and 17 has to add up to 32. Those are the yellows. Everybody with me? Now let's clean these up a little bit. X plus Y equals, let's subtract 21, 22. And X plus Z is 13. And Y plus Z is 15. Everybody's still with me now? Okay, so you can solve this however you want. I think I'm going to use elimination, and a real handy trick is, go ahead, I'm just going to add these two together. So I'm going to multiply this one by a negative, and when I add them, I get Y minus Z equals 9. These cancel, so Y minus Z equals 9. But look at the one on the bottom. Y plus Z is 15. So now I can get rid of my Z's. 2Y equals 24, and it looks like Y is 12. So I can put a 12 right there in the Y spot. Now, if X plus Y is 22, but we already know Y was 12, then it looks like X has to be 10. And if 12 plus Z is 15, it looks like Z is only 3. Okay? Now, questions. If one student is chosen at random, so remember there's 68 of them, so I'm going to reach in the box and pull one out. If one student is chosen at random, what is the probability that he will like at least one color? Now, how many kids like it? Don't all these kids like at least one?
Yeah.
Right, all those, I don't know what those add up to. I know this one adds up to 43, so 43 and 18. I think these only add up to 61. Check my arithmetic. That could be wrong. But I think that's right. So if those all add up to 61, there have to be 7 out here. Those are the kids that don't like any of those colors. But what was the question? What's the probability that you'll get a kid who likes one of those colors? 61 out of 68. 61 out of 68. Okay. So I gotta erase some of this. Are we good with that problem, guys? You've done 2 of those. Everybody okay? All right, now we're doing a similar thing with a Venn diagram. Not quite as complicated. And it's involving just probabilities. So, let's look at what this means. Somebody has said that the probability you like apples is 0.6. And the probability you like bananas is 0.5. And the probability that you like both, this is both, this is A and B. The probability you like apples and bananas is 0.2. Alright, so here's our Venn diagram. These are the people who like apples, the people who like bananas. Now, the only section, the only one of those numbers that you can put in your picture is which one, do you know? Only one of those is going to go in the picture. Which one's going to go in? 0.2. We know that the overlap is 0.2. Now, why don't I put the 0.6 in? Because the 0.6 is the whole circle, and I already have 0.2 of it accounted for, so this would be 0.4. What are those people? Those are the ones that like apples, but they don't like bananas. Alright, if the whole banana ball is 0.5, 0.3. Perfect. Now, these are probabilities. The P stands for probability. In any scenario, probabilities have to add up to 1. So right now, I have 0.4, 0.2, and 0.3. I'm missing 0.1. What are those guys? Those are the guys that don't like apples or bananas. All right, notation. This says, what is the probability that you like apples, but you don't like bananas? This is called the complement. It's the not. So apples and not bananas would be, apples and not bananas would be 0.4. And then not apples and bananas would be 0.3. And not apples and not bananas would be these guys right here.
Can you explain to me how you got the 0.4 and 0.3 again?
The whole apple circle is 0.6.
Alright, I would take the 0.2
As soon as we put 0.2 right there, that's inside the apple circle, right? Okay, number 9. Try do the same thing with your, oh wait, I haven't done the last one, I forgot. I have the probability of A given B. Okay, so let me say that again. This is another new notation. This is the probability of A given B. Okay, now, there's a formula for that. It's very, very simple. The formula, I'm going to erase this. The formula for this is the probability of A and B, that's A and B, over the probability of B. So when you are asked for a probability set, because it's called conditional probability, this is the probability of A given B, your math strategy is do the probability of both and divide it by the probability of just B. I know it's hot in here, London. I'm so sorry, it's not, I mean, I was sweating earlier, it's actually cooled off a little bit. Okay, so what was the probability of both?
Point two.
Point
Point
two.
two.
This is both, A and B, both.
Which is the middle?
So 0.2, and then what's the total probability of B, the total?
0.6.
Total B.
Oh, 0.5.
Point six.
What's
Point
B?
five.
Five.
Oh, it's point five. You gotta do it. 2 and
So 0.2 divided by 0.5, that would be 0.4, I believe.
So you put point four. Yeah.
All right, now, you and your partner try number 9. It is exactly the same question, different numbers.
Point four. Point four. Wait, is it? Oh, probability, it should all add to 1.
Yeah, I guess.
The probability.
So these add up to
No, 0.75. So 0.35 or 0.75. Yeah, like I did. I actually beat this board here, actually.
All right, I've got my answers up here. I don't know if they're right or not. You can check them for me.
Why do I not see? Yeah. I got 0.875.
Ron, you need to pay attention to the order of the letters. Numerators are easy, because I just looked at the denominator.
I don't think it matters if you.
Oh.
Don't round it off, it matters.
69.7.
Guys, we're gonna try not to round off, so if you get a decimal, you have to round off, just hit math frac, the fraction form of it. Because we're trying hard not to round our answers. All right, anybody have a question about that? You think you got it? All right, we have one more kind of probability. So Joe, the 9.3 number 2 homework is gonna be due on Thursday, okay? Just getting ready to finish it right now. We have one more kind of probability. And that is number 10. Read number 10A. We're all reading number 10A. So Sam will turn the page and read number 10A.
Really good.
All right, so this is actually an example of a conditional probability situation, but this one is set up totally in words now. Okay, so we gotta figure out all of our own numbers.
There's Venn diagram still in there,
Not gonna do a Venn diagram. We're going to use a tree diagram.
right? Oh,
So here's what I want you to think about. There are two things happening in this problem. The two, we call them events, but it's kind of a dumb word. But the two events are raining and doing homework. Those are the kind of the either ors we have in the problem. Do you agree with that? The ultimate question involves which one of those? Is the ultimate final question about raining or about doing homework? Doing homework. So whatever the question is, in this case homework, that's gonna go at the bottom of our tree. So the first step is going to be rain or not rain. So it is either gonna rain or it's not going to rain. All right? And then, if it rains, he's gonna do homework or not do homework. If it doesn't rain, he's gonna do homework or not do homework. Do you follow that? Okay? So now, we're gonna fill in on each one of these little branches, we're gonna put a number. So let's see. If it rains, it's raining. The probability that Joe will do his homework is 0.4. So this branch right here is 0.4. Because it is raining and we're doing homework. Now,
So that means 26.
this one right here has to be 0.6. Because if it's raining, Joe's gonna do it or not do it, and that's gonna add up to 100. So each of these little V's has to add up to 100.
21.
All right, now, what if it's not raining?
21.
If it's not raining, his homework probability is 0.1,
0.9.
which means his not homework probability is
0.9.
0.9. Given that the probability of rain is 30%
And then 0.7.
and 0.7, we want to find the total probability that he will do his homework.
4.5.
Now, would you agree that Joe can do his homework two different ways? He can do it on a rainy day, or he can do it on a not rainy day. So, here we go. Gotta come all the way down from the top, all the way down. If it's gonna rain and he's gonna do homework, it's 0.3 times 0.4. Remember those very first problems we did where we were picking M&Ms out of a bag? If we wanted red and green, we multiply. And means multiply. So we want it rain and we want a homework. Or,
0.7
that's
times.
gonna be a plus.
0.7.
We want not rain and homework. So these two multiplied, 0.12. It is my fervent hope that you can do that in your head, but if you can't, type it in, don't miss it. 0.12 plus 0.07. So the probability that Joe will do his homework, no matter what, just period, the total probability, someone's phone was ringing, but oh well. 0.19, you okay with that? All right, now we're gonna do problem B. You're gonna do this, you and your partner, but before you start, I wanna make sure you have your tree set up correctly. So, in problem B, what are the two things?
Salad and
Rain
noodles.
and homework, what do you got?
Noodles and salad.
Noodles and salad. So one of them's gonna go here, and one of them's gonna go here. So what is the question?
Salad.
Salad, so salad goes on the bottom. So you're gonna start with noodles and no noodles. And then you will do salad and no salad. Alright, so go ahead. You and your partner,
And out.
see what we can come up with.
Yeah, she was.
If the cafeteria serves communication and if they don't serve, I wouldn't have given they serve more than the top probability
Do they serve you?
He does.
they serve. So it's point or oh, because the 8% doesn't serve in salad. If they serve more products, so that's a point. Yeah,
We would see you guys.
It'll be since it's once a week, it's point two.
They serve salad, so point two.
I could be wrong though.
So how many days in school week? School week, 5. 1 out of 5. Okay, so what's 1 divided by 5?
Dude, I think 0.56. Yeah, I have, okay.
Just once in school, so I'm the one to
Is that
Yeah.
I got 0.56. What about you?
Yeah.
Ronan, why are you staring blankly at the board? What's going on there?
No, I just don't. I feel like
All right, one more, my friends. Who would like to come up and do it? Would somebody like to come up and do number
I'll do it.
letter C? Here.
No, I'm just joking.
What's gonna go in the tree? We know we're gonna have this situation.
Soccer's on
first.
top.
The first part.
So soccer's up here, so soccer and no soccer, and then lacrosse and no lacrosse. Survey, guys, come on, get focused. Let's go. Might need a calculator for this.
Yeah.
What do I want?
Never see that, dude.
I got 5, 7, 8, but open to,
What'd you do? 0.7 times 0.62 plus 0.3 plus times 0.48.
add them together. All of my examples, unfortunately, ask, you know, like, what's the probability of lacrosse? I could have asked, what's the probability of not lacrosse? And then you would have used this one and this one. Does that make sense to you?
Yeah.
You can ask either one. All right, we good? I think it's lunchtime.
11:40.
So I will see you back at, let's see, I'm supposed to see you at 12:05. I'll give you till 12:07. 12:07. I'm sorry, I didn't make the rules. 12:07. We'll get cooled off. Hopefully it's cooler somewhere else.
Is Jalen tired?